All right, here we are, PACS. So PACS is just one lecture. However, it's a huge field, right? It's a career path that you can possibly get into. Maybe at this point you've met some PACS administrators. Some hospitals just have one. Some others have like a whole team of people. I guess the best PACS administrators usually are RTs versus people that have like a computer background and no radiology or radiography background. So it is good for us. There's different levels of PACS slash IT. You know, there are people that just replace a keyboard or fix some hardware or install some things, not too hard. There are people that train the radiologists on how to use the voice dictation Dragon software, usually. And that stuff is not really new to you anymore. I remember when like voice to text was like, you know, you had to buy some big software. Now I voice to text my messages sometimes. So they have people out there that train radiologists on how to use PACS to their advantage. And then there are even deeper people that have big computer science backgrounds that do programming and, you know, that really nitty-gritty stuff. So that's also an option that definitely would need more school for the majority of you. There's an additional license that you can get known as CLIP, C-L-I-I-P. You have to score a certain number based on different things you've done in your life to be even able to take the exam. I can take the exam. But I'm not CLIP certified because I'm not interested, really. But yes.
So be one of those the maintenance people that fix the tubes and the machines.
So that's different.
That's different.
Yeah, that's so there's a difference between PACS administration and just, you know, installing, fixing, and QAing and all that stuff, the machinery. That's a whole other field.
You don't have to get this degree to do that, right? To fix the machine.
I don't think so, but you can ask Jody Ann. When those people come and they service our machines, maybe she can hook you up and you can ask them a couple of questions, like how'd you get into this thing? Just like PACS, some of them, you know, are just trained on the job or have a mechanical engineering background. So it might vary depending on what they're required to do. So yeah, our field, I didn't even mention sales and I didn't mention applications. So those are two other avenues. Sales makes sense. Applications is the person that goes in and shows a group of RAD techs how to use the new C-arm once you purchased it. Like trains you on it, like a trainer, essentially. So those are all kind of, and then of course there's teaching. So there's a lot of stuff there, but today it's all about PACS. And you're using it already. When I first gave these lectures, PACS wasn't everywhere. Now it's everywhere. It's international, not just national. They have conferences on PACS. You wouldn't buy any equipment that doesn't work with PACS. So if your equipment is not what's known as DICOM compliant, which is a standard we'll talk about later, kind of PACS and DICOM sort of go together. It's like PACS is the person and it speaks DICOM. You wouldn't buy equipment that wasn't compliant, even down to things like the monitors and not just, you know, a CAT scan unit or a linear accelerator. It's getting used all over the place, but it's best known for its database capability, that in terms of storing multiple images and the reports that go with them. PACS is getting utilized outside of just radiology, right? The pathology department is using it to take pictures of specimens and pathology and putting those images into PACS. It's being used not just for radiography, but also in CT, ultrasound, nuclear medicine, bone densitometry, mammography. I don't know. Anything else I missed? Probably DEXA. A few things, and they keep adding to the list. So it's been really a success story over the years. It stands for, so it's an acronym, Picture Archiving Communications Systems. So of course, pictures we just talked about, one of the nice things is that you can have remote workstations all over the place. You can have simultaneous users all viewing an image at the same time. If you can imagine, one of the downsides of having film was that there's just one piece of film. And if it goes missing, or if someone in New York and in LA want to look at it at the same time, they can't do that, right? You'd have to, take a picture of it or something. Not working. So now it's great for collaborative work. It's great for not losing it, although things go missing in the digital world as well. And mistakes get made. You used to be able to change a patient's name by crossing it out and putting a sticker on a piece of plastic. Now you have to call people and grovel and say, I kind of screwed up, barcoded the wrong thing, or clicked, because now with the work modality lists that are very, very nice, we'll talk about those in a second, you can still click on the wrong patient very easily. So, good stuff with PACS. Unfortunately, the poor people that worked in the file room were all fired. There are no file rooms, so to speak of, anymore. Even the techs that I've heard that are going out in a van, taking x-rays at nursing homes and other facilities are using digital technology, which, by the way, CR and DR, the lecture before this, which you hopefully watched the videos about, is really what made PACS possible, right? Because PACS is based on keeping digital images. Digital images are only around because of CR and DR. And I don't know who this dude is, honestly. You could probably read more about PACS. It's been around for a little while, since the 90s. He's the father of PACS. He's like right up there with me. No one knows Tim Berners either. He's the guy that basically founded the internet. So, or the World Wide Web.
So his picture is not going to be in the exam.
Yeah, I should have like a picture of like different important people. You guys will get ranking, but will you get like some of the other pioneers like Gottfried? No? See? My picture?
Yeah, localization.
Globalization. Okay. You can comment on one of my videos, maybe. But make sure you watch the ad and pay me like a nickel. All right. So what's it all about? We need the devices we've been talking about. So if you don't have the imaging systems, then there's no image to acquire. Essentially, PACS at its heart is a big database, so it's a keeper of records, a big repository for data and information. It comes with specialized servers. So a server is just a fancy computer that usually does one thing. Like a mail server is responsible for email, right? A print server, in a company, everyone's hitting print, but the server organizing it all and sends it to the printer. So your PACS server, and there's many of them, is where your images are stored. And when you go to a workstation, your image is not there. You make a request, and it goes out and gets the information. Right? It's a very complex system, but for the most part, from the user end, it's not that hard. Right? It works with accession numbers, which are specifically linked to exams and dates. And that accession number sits underneath a medical record number, right, for the patient. Right, so patient has one medical record number, hopefully, right, because if they don't, and it's still the same patient, that's where things get all crazy. But they can have many, many accession numbers associated with that patient medical record number. It feeds information from the hospital information system, which is HIS, but also the RIS, which is the radiology information system. So that's kind of nice. They're not directly part of PACS, but they communicate with PACS. And of course, like we said earlier, multiple people can look at an image at the same time, which is really nice. I mean, it speeds up things. Let's say you're having a CAT scan because someone just hit you with a bat, and you have to go to the OR, right? Before you even get to the OR, people are prepping the room and looking at the images up there after you just took them, right? You don't have to I've seen this in the past when we worked with film. You used to take the films in a little leaflet or, I don't know, folder thing, and actually put it on top of the patient, and it sent it up with the patient, right? And that's when they saw the images, when the patient got there. So now, it's kind of nice, right? So there's been a lot of efficiencies built into PACS. But you can see, and this is the short list, you have this is kind of PACS here as your control computer, but you can see many different modalities, MR, CT, CT, digital fluoro, even OR stuff, ultrasound, etc., all feeding into PACS. At the same time, some of the patient data doesn't have to be recreated. They're getting that from the RIS and the HIS, right? So for example, patient comes to the radiology department and says, I have an order to get my ankle x-rayed. Let's say they've been a patient before. So still need a human for this though. Secretary or whomever goes in, finds that that patient was indeed in the hospital several years ago. A lot of their information is still there. So they feed that information from the hospital information system into the RIS, and then they add in the ankle. And then you go to your DR room and your work list is populated for you. You double click and you're done practically, except for taking the x-rays. Of course, PACS is also available over the internet. So a colleague in a different country can be viewing the same information that a radiologist or physician here is looking at, which is really nice. And the only issue that we have right now, not a huge issue really, but would be nice in the future, is if you have 3 x-rays done in 3 different states, then chances are you're only seeing one of those x-rays, at that one institution, right? So things aren't nationalized just yet. We're a little bit behind electronic medical records the way Europe is. Europe, you can go to different countries in the European Union, pull out your card, your number is linked to all of your stuff all over the place. They're starting to do that a little bit here and allow systems to communicate better. I told the last class that I recently went to a general physician at Mount Sinai, and they were able to see that I went to a dermatologist associated with Cornell. So so things are actually crossing hospital institutions. So we'll get there. So here's an example of the HIS. Nothing major here, and a lot of information that's in the HIS we don't need. We don't need all that billing information for us to actually get an order to take an x-ray. We don't need to know that, they skipped a payment somewhere or whatever it might be. We only really need to know things pertinent to the x-ray. The RIS, that's a little bit more, important to us because there are fields in here, of course, for patient name and ID, but date of birth, study time, the acquisition number, the modality, and the list goes on and on. Actually, all of those terms are actually what's known as DICOM attributes. And a lot of that stuff is linked to every digital image you take. So back in the day, you had name, medical record number, maybe there was like a procedure code or a session. I think we had a session numbers, even though we didn't use them as part of PACS. And that was it. Now you can pull up an image, and if you know where to go, you can see the matrix size that the computer used and just a ton of information. That a lot of it we don't really need, again, for our actual x-ray. So as mentioned, HIS and RIS, not quite part of PACS, but feed into PACS. They have their own text language standard, which is Health Level 7 or HL7. DICOM is the language that PACS speaks. DICOM, you'll see in another slide, there's a lot of different DICOM standards. I think about 24 of them that you don't have to memorize, so don't worry. But they govern many, many different things, and all that information is important. You wouldn't go out and buy a CAT scan unit unless it was DICOM compliant. So I think we can pass a little bit on this. And it's all over the place. I remember when I first put this slide in here a few years ago, I thought that's really cool. This is just like no big deal anymore, right? Oh yeah, image on a tablet, right? So radiologists can read images. I really hope they're not looking at their images on a phone now. That's getting even, you know. But these are great tools to go over an image with a patient, right, sitting next to you. That's helpful. To actually make a reading off of an iPad or something to that effect. I don't know if the FDA is cool with that yet. I read an article once where they took one into the OR and they sterilized it and everything. They encased it in plastic first, but then they sterilized it and used an iPad in the OR. Legacy PACS is pretty much gone. Now everything is web-based, so physicians can not only see things wirelessly, but they can have their own monitors at home, which is kind of nice. There was a time where radiologists had to get called in to the hospital to look at an image. It was kind of a drag. Right now there are companies, one's known as Nighthawk. So I believe it's an Indian company. So at 3 o'clock in the morning at some little hospital in upstate New York or anywhere, they can have their images read in minutes, maybe an hour, by a radiologist in another country, and we get the report here. Right? Usually radiology is a 24-hour timeline for readings, if not much faster than that, right? So legacy PACS is pretty much gone. Web PACS is where it is, and it's integrating with so many different things. And these are some of the key terms that we've been talking about. It's utilizing DICOM as our standard, along with health level 7 and IHE. Forget what that, integrative health environment, something like that, or enterprise. Easier to link electronic health records, electronic medical records. As I mentioned, we're not quite there yet. You know, if I have a medical procedure done in another state, no one's probably going to know about it here unless it's part of a specific network. Certainly if I go outside of the country and have something done, probably it stays there, right? In theory, your health information should be able to follow you everywhere. Now, maybe there's a downside to that, okay? Maybe I don't want my podiatrist to know about my mental health issue, perhaps. You know. So there should be opt-outs and opt-ins all over the place. Prefetching, that's nothing really that important anymore. I mean, it's the ability for a radiologist to go walk in the morning and have a whole bunch of cases already preset for them to review. So so the computer, I say they, the electronic, right? But the computer system has prefetched, has already taken those images that are up for reading. So the electronic health integration, and I did a whole class on medical informatics. It's a fascinating field. There's a lot of potential there. There's a lot that you can do with data. I mean, we've all heard about in New York State that you no longer are able to get handwritten scripts for prescriptions. Everything is digital now. And that's because no one could read the handwriting of physicians. And a lot of people died because of that, literally. But in addition to just electronic ease of use, let's say a physician didn't read, the journal that came out last month that talked about this one medication having a bad interaction if the patient was taking this other medication. And now, because you can have that, it's called COPE, Computerized Physician Order Entry. It allows a physician to put in a drug, and then it'll look for interactions and not just things that have we know about for a long time, but maybe even a scholarly article that just came out, right? That who would know? You can't expect doctors to know everything on like a daily basis, you know. So there's a lot of power in the data. Of course, some of this stuff came out, you know, through the Department of Defense, but not just them, other government entities like NASA, and you know, things that are getting used in outer space. Anyone catch the launch of the Falcon Heavy last Thursday? You know, the one that looks like 3 rockets stuck together? They landed all 3 of them back. It's pretty amazing. One of them on a boat. The boat has a cool name too. The boat, what's the boat's name? I think I Still Love You. Yeah, that's Elon for his naming conventions. So cool stuff happening. So let's see if this works, and maybe we might not watch all of it. Ooh, AGFA.
Hi, my name is Charles Morris, Senior Marketing Manager with AGFA Healthcare, currently at the SIM 2011 conference, where we are highlighting our PACS Data Center Medical Imaging Repository. So today I'd like to speak to you about the PACS Data Center Medical Imaging Repository and how to image enable your EMR. As you're very aware, medical imaging is exploding across health systems today. Traditional departments like radiology and cardiology, while they're generating lots and lots of images, are fairly flat in their growth. The departments that are elsewhere inside the enterprise, the growth is significant. And today's health systems want a mechanism in order to help their organization manage these images. So I'd like to speak a little bit about what is an EMR in healthcare today. Most organizations have a core clinical information system that helps manage multi-departmental workflow, results, orders, and things of that nature. Most organizations have a system by one of the core key clinical information systems vendors, such as Epic, Cerner, GE, etc. These organizations also typically have a document management system, and this document management system is in place because it manages a different type of data than the core clinical information system is designed to manage, such as registration, consent, discharge forms, typically paper documents. Organizations also have imaging systems that are represented in individual departments. Most of these imaging systems are owned and managed by the department, but do not have an equivalent enterprise system that is on the level of the clinical information system or document management system for the enterprise. Each individual department may be creating images on its own. It does not necessarily have an enterprise system on the level of the clinical information system or document management system. So the electronic medical record is really, at this point, a combination of the clinical system and the document management system, and maybe they might have one of these individual departmental systems integrated into the EMR, if you will. But there is a large gaping hole in the strategy that there is an enterprise level system that helps manage multi-departmental imaging. This is where a medical imaging repository can help resolve the problem by providing an enterprise level platform that is on level with the clinical information system and document management system that provides a universal method to acquire, store, exchange, and provide visualization of medical imaging across the health system. So let's speak a little bit more about what constitutes a medical imaging repository. The medical imaging repository really consists of 4 core pillars or services.
It says imaging EMR, but it's really enterprise.
So the medical imaging repository, or as some folks are calling it, the imaging EMR, really constitutes of 4 core pillars: capture, storage, exchange, and access. The primary function of the capture functionality is to provide multi-departmental turnkey imaging workflow. The medical imaging repository must be able to enable the enterprise to provide capturing of medical imaging data that has high quality demographics, high quality study identification, and also has the ability to provide services to the department that the systems in that department can integrate to.
DICOM.
The storage pillar, or storage services that the medical repository must provides for multi-facility vendor-neutral archiving.
All right, we'll come back to you
Must
another
provide
time.
Strong standards.
All right. So DICOM, which we said really integrates itself as the language of PACS, stands for Digital Imaging and Communications in Medicine, even though it says O. I guess the I didn't work out right. It would have been DICOM or something. In any case, its use has been around and it integrates with almost everything, right? And as I mentioned in another class, even the images themselves are formatted in a DICOM format. So you can't look at them on a regular computer unless you first convert them to something like a JPEG, or if you have the actual DICOM software. I know we mentioned this, or I did in one of our classes, where you hurt yourself and you want to take your images, so they give you a CD, and on the CD, in addition to your images, is the software provided to actually show you those images. Of course, even CDs are gone now. Now you're just getting access to the database itself. Just go look at the image instead of someone burning it. Who burns CDs anymore? You burn CDs?
No, we have to do that for our future.
Yeah, right.
Oh. Well, okay.
So they still do.
So I know it's still out there, but they're moving away from that, right? And just giving people limited access. Like your physician can be given certain, allowances to go look at an image. And DICOM's been around for a long time, since 1993. He'll talk about it for just a minute or two. Let's see what he might say for a minute.
Hello.
Hi.
I'm Joel Bartholomew. Welcome to this edition of Connected Health. What you see behind me is a container railroad car. Neither you nor I can see what's inside. But if you were the railroad or the owner of the products inside, you would have that information and more. So you would know what was being shipped and when it would arrive at its destination. In medicine, we make a distinction between visible light medical images, like X-rays and CT scans, and those we can take with a digital camera. We give file names to the photos we take with our cameras when we save them to our computer's hard drive. That helps us find a picture of our loved ones. A file name is good enough for our personal photos, not, however, for medicine. Not if we're going to save important medical images of a patient and make sure they go into the correct electronic medical record. Too many people have the same name, and it's too easy to duplicate a file name. I do it all the time. Back in the 1980s, the DICOM standard was developed to handle, store, and transmit information, primarily of radiologic images. DICOM stands for the Digital Imaging and Communications in Medicine. In this format, additional patient information we call metadata is wrapped around an image. We can attach disseminating data, like a patient's name, social security number, insurance number, blood type, and age to an image.
All the things that make hackers
Having
happy.
these identifiers helps a physician call up the right images when he or she examines a patient's medical record. Taking pictures of a patient is a very good idea. But you can understand that an image in DICOM format is even a better idea, especially when a doctor has a practice with thousands of patients. Images saved to an electronic medical record should be in DICOM format because we may need to access the relevant information inside the boxcar. Here's why. The DICOM headers allow clinicians to search for similar cases that may help them form a diagnosis and a successful treatment plan. Let's say the doctor would like to query his EMR for images of all 53-year-old males who have a very specific dermatologic problem. Of course, the results do not reveal the identifiers of the patients. It just provides the details of their cases. This is how a lot of medical research is done to benefit the entire medical community. And data that isn't in DICOM format and is strictly for one person is in fact a dumb data. Have you seen my earlier blog, episode number 2, in which I pointed out the disconnect that often occurs between urgent care centers and pediatricians? When parents decide urgent care is more convenient, or their children have a medical issue
Okay, so
after the pediatrician.
I'll let you get back to him on your own time too. But here's a little bit more about DICOM, right? It covers the rules related to, some very important things like how to exchange messages. One of my favorites is part 12, which may have changed in terms of the part numbers, because these things keep getting updated, but grayscale standards, so that you're looking at an image in 2 different locations. If the monitor is DICOM compliant, then the grayscales of all the pixels match each other, right? So that's kind of an important one that is easier to make sense of. There are some security systems involved, but hackers love hospital information. Hospitals have not secured their data the way banks have, for example. And really, anyone can steal a lot of information from a hospital system and insurance companies that have some of that same information, and recreate you and get credit cards and driver's licenses and all sorts of stuff. Because when you go for an operation, you give them everything, right? When they ask for social security number, you just give it to them. When they ask for the address, you give it to them. Basically they know everything about you. So the DICOM header, he mentioned a little bit. Every image that you take contains tons and tons of what he calls, and is commonly referred to as metadata. And it's everything besides the things that you would expect, like patient name and the date, and that information, but it's things like the matrix size. In CAT scan, they'll give you the field of view, they'll give you the amount of radiation that was used. All that stuff can be tracked at, and a lot of this stuff is available to the public, where they anonymize important information. So they take off patients' names. I hope you're doing that for your case presentations. You shouldn't be walking around with anything with a patient's name on it. That's a HIPAA violation. I don't want to know about it, really. But that data can then be searched and looked at. So, research is done in entirely different ways now. That's nice. For instance, a department can see what the average radiation dose is for a particular exam to see if they're in line with everyone else, for example. Images need to be stored. Images are getting bigger and bigger. Average CR image, this is one view, 4 to 5 megabytes. So, for example, a 5-view lumbar spine, multiply that by 5, you come up with about 25 megabytes. But you can see CTs are going to get up there, and MRI is up there. And every time that you recreate the image and do something else, change the contrast, create a 3D model, you just create even more data. So memory is pretty inexpensive, but enormous amounts of data out there. Did anyone see some of the images of the new black hole that they were able to capture for the first time? What got me was not the image of the black hole. It was the image of the researcher standing in front of a desk with, like, I don't know, 50 hard drives or something that each had, petabytes of data, which, is like 3 levels above megabytes. And the other thing we have to think about is everything has to be backed up in our system, because you don't want to lose the data because you have a flood in your PACS room and your jukebox or whatever you're using to keep your images on get messed up. So you have to take all the data, compress it. There's a couple different ways you can compress data. There's lousy, which is a compression technique that's pretty good, makes the file size smaller. Have you ever tried to send an email and it wouldn't go because the attachment was too big and you had to like zip it, right? So that's a compression technique. But in the case of lousy, when you do reconstruct the image based on that backup data, it's not going to be as good, right? It's going to be a little bit noisy, you're going to lose some resolution. If you use lossless, think about it, the actual word means you're not losing anything. So it's not the best compression method. It's basically a duplicate, right? And you're not going to save a lot of space. But we have to keep our information for about 7 years, right? And a lot of these jukeboxes that are optical are going away. They're being replaced by standard solid-state hard drives that don't have like a mechanical mechanism in there. So that's as we speak, things are changing, which is kind of cool about this side of the job. But I've seen these things work. They're kind of slow, but they look cool. Like there's a little arm that goes and kind of like takes the it looks like a record, but it's just like a shiny DVD, and flips it and puts it where it needs to go. That stuff is going away and being replaced by much faster solid-state hard drive technology. But it's pretty cool. The fact that you can access PACS from basically anywhere on Earth, essentially, with satellites and whatnot, is nice. So, for instance, you would be given a unique URL. Everyone know what a URL is at this point? Anyone know what it stands for? What's that?
Forgot.
I think it's Universal Resource Locator.
Yeah, that sounds about right.
Sounds good?
Sounds about right.
Everyone knows it as that's what they give you when they give you like a website that's cool to go to. Right? Here's the URL, right? But there's a URL linked to your images, right? So a physician gets that, and then they can access your images. The backup system that you'll find on an exam, the one that we're using in medical imaging is known as RAD, not the bug spray, right? It's a random array of independent disks. And essentially, we need to do that because we have to keep these things on file for about 7 years. When PACS was first implemented, what did you do with all of the patient's previous actual films? That was a big pain. They had to digitize them, put it through like a scanner, turn that plastic into digital information, and then store it with whatever new images would show up. So that was a big project for a lot of places. DICOM has really helped because when people had PACS and then went to a new PACS unit, that was another big problem. It's like, how did you get the information from your old PACS to your new PACS? I mean, people were like employed, and I remember some of these transitions from one manufacturer to a new one took months and months and months to achieve, and they were huge projects. I mean, you could look at it as financial security if you're involved in that. It's like, being a construction person on a building that never seems to end. It's like kind of, all right, job security, I guess. Okay. If PACS does go down, well, and that's where those laser printers come in, right? You can still create a hard copy if you really have to, but who wants a hard copy? Right? Everything's in the cloud somewhere. Just ask Amazon. They make probably a good chunk of their money, not from selling, Game of Thrones stuff, but from doing cloud-based selling data storage to companies and people. Amazon Cloud Services, look it up, it's huge. Okay, that's it.
All right.
Enjoy.
Awesome start.